So we spent all this effort designing the ultimate dry suit in terms of flexibility, streamlining underwater. It's called the fusion suit. What we found was that there wasn't a undergarment on the market that could keep up with the mobility of the dry suit. We looked at Thinsulite, we looked at Primaloft. They're all great materials. Unfortunately, they don't stretch. What happened was we ended up much like the fusion suit. It's built as a 2-layer system. The inner core is cut oversized, and then we use an outer stretch fleece layer that sucks that core in tight. And then by sucking that in, the mobility increases, the air transfer within the suit is much better. We've put some 3D mesh into areas near the inflate and exhaust valve. It's called the air transfer system, and relief zipper options, and that was the basis for the thermal fusion. We have a slogan at White's. It's designed by divers, proven by science. That's where we contacted Spin, and Spin took our undergarment into their test facilities and ran it through a whole series of tests against our competitors' undergarments, and I must, basically the results speak for themselves.
The Spin Centre's main goal is to take the needs of a high-performance sport community here in Canada and build technology solutions customized to their specific applications.
What we did in this particular project is we looked at 4 different undergarments that are worn underneath dry suits in the dive industry. So we used some methods that we commonly use in physiology and understanding how athletes or individuals in demanding occupations work in extreme environments to quantify how well these undergarments actually protected against the cold. What we found when looking at the different garments was that the thermal fusion garment provided excellent insulation, and that deep body temperature did not vary really whatsoever when immersed in a cold water environment or cold air environment during light exercise. Relative to the competitor's garment, the thermal fusion protected the diver much more effectively, and skin temperature dropped, for example, in the competitor's garment by over 5 degrees in 30 minutes, whereas in the thermal fusion garment dropped by less than 2.5 degrees. So there was a significant difference in thermal protection. And if you think about how the body cools down, heat flows from a high temperature to a low temperature. So if skin temperature is low, heat's flowing from inside the body to the outside of the body and then to the water. So skin temperature is a very, very important variable to regulate. And as I said previously, the thermal fusion garment performed marvelously and prevented any drop in deep body core temperature, which is the key variable we're looking at when we look at hypothermia.